Assalamualaikum and hello guys, we are from group 19 and we will explain more about our notes through this video based on our example question. Without further ado, let's start with a row reduction. Based on the note, we've been introduced into two methods which are Gauss elimination that have 5 steps and Gauss-Jordan elimination with 7 steps. In this video, we will focus on Gauss-Jordan elimination. Is an example of Gauss-Jordan elimination method. Based on the question, solve the system of linear equation by using Gauss-Jordan elimination. The first thing that we need to do is we need to change the linear equation into matrix, like what being shown on the right of the equation. Based on the note, our first step is we need to find the most leftmost column with a non-zero entry to produce leading one at the top of the column by ERO. Since on our matrix we already have the one for the at the top of our column, so we don't need to change anything. So we will continue with step 2. Based on step 2, we need to use ERO to make all entries below the leading one into 0. So we will subtract that new R2 equal to R2 minus R1, while new R3 equal to R3 minus 2R1. Now we will move on into step 3. So step 3, we need to cover the row with the leading one, then repeat step 1. So now we can focus on row 2. We have -2, so we need to make it into 1. So we will subtract that new R2 equals to R2 divided by -2. After that, for step 4, we need to repeat step 2 to perform ERO to produce 0 at all entries under the leading one. So we subtract that the new row 3 equals to R3 plus R2. Based on the step 5, we need to repeat step 3 until the matrix is in row echelon form. So we subtract that new R3 equals to R3 divided with 1.5 or 3 over 2. Now, since our matrix is already in row echelon form, we will move on into step 6, which are at the last non-zero row, we need to perform ERO of each row above the leading one to become 0. Based on step 6, we subtract that new R2 equal to R2 plus 1.5 multiple R3 and new R1 equal to R1 plus R3. Last but not least, the step 7, we need to cover the row and repeat step 6 row by row by moving upward to get reduced row echelon form. So, we subtract that new R1 equal to R1 minus R2. Now, since we already complete the 7th step of Gauss-Jordan elimination method, we will have the final answer, which x equal to 6, y equal to -1, and z equal to -2.
Hi, so today I'm going to talk about how to solve system linear equation using inverse matrix. The matrix must a square matrix like 2 times 2 or 3 times 3. The matrix must have determinant. Determinant cannot equal to 0 because if determinant equal to 0 then the inverse matrix don't exist. So here is the formula. The given equation is A times x equal to b. So here is the example of the equation. So we need to find x. So the formula is x equal to A inverse times b. So A is the coefficient matrix, B column of constant, and X column of variables like X, Y, and Z. Step to solve the system linear equation. First, find the determinant. Second, find the inverse matrix. And the last one is use the formula to get X. So here is the formula how to find the determinant. So the left one is for 2 times 2 matrix and the right one is for 3 times 3 matrix. Note that determinant must not equal to 0. So the formula of inverse matrix is A inverse equal to 1 over determinant of the matrix times the adjoint of the matrix. So here is the in some example of inverse of 2 times 2 matrix. So here is the example for how to calculate the inverse of 3 times 3. First, calculate the adjoint and then insert the adjoint into the formula. So we get the inverse matrix. So after we get the inverse matrix, we can insert it into the formula to solve the system linear equation. So we can get the unknown variables. So that's all from me.
Okay, now, firstly, we will discuss about 2 by 2 inverse matrix to solve the linear equation. First, we need to write the matrix write the equation into matrix form like this, and then we need to label them with A, B, and C. And next, before we start to the solving method, we need to check first whether A, determinant of A is equal 0 or not. And then we will get AD minus BC equal to 10, which is not equal to 0. That means A have inverse matrix. And we can go to the next step, which is try to find inverse of A using this formula. When we fill in the formula, we will get this form, and then we solve it, which is we get 1 over 10, 2, 4, negative 1, and 3, and we simplify it to 1 over 5, 2 over 5, negative 1 over 10, and 3 over 10. And for the final step, we will solve using this equation, which is B equal to A inverse times C. We will get like this, with 1 over 5, 2 over 5, negative 1 over 10, 3 over 10, times negative 16 and 8. And we solve it just like usual, and we will get 0 and 4, and that means K equal to 0 and equal to 4. Okay, now let's move on to the solving system linear equation using inverse 3 by 3 matrix. First of all, as usual, we will write the system linear equation in matrix form, and then we will label them as A, B, and C. For the next step, we will check the determinant. In this case, I will using the row 3 because it's simpler than the other two row. So we will get this. We will get like this. Negative 14 minus negative 6 minus 8. And the answer is negative 16, which is not equal to 0. So A inverse is as this. For the second step, which is inverse for A, and this is the formula for inverse in 3 by 3 matrix, 1 over determinant of A times adjoint of A. And what is adjoint? Adjoint is a cofactor of A that will be transposed. Okay, now for the first step to find the adjoint of A, we need to first calculate the minor. As like this. After that, we need to turn minor to become a cofactor, which is just apply the formula, and we will apply this formula and we will get the cofactor of A. For the next step, we will transpose the cofactor A to become the adjoint A. then we can calculate the inverse for A. Finally, we will solve the linear equation using the same method as the 2 by 2, which is B equal to A inverse times C. We'll get like this, and just solve as usual. And lastly, for the final answer, we get x equals 7, y equals to 1, and z equal to 3. So that's all from me.
Today we will learn how to solve a system of linear equation using Cramer's rule. Cramer's rule apply when we have system of n equation with an unknown and determinant of the coefficient matrix A written as determinant A is not equals to 0. The formula for Cramer's is xj is equals to determinant of aj divided by determinant of A for j equals to 1, 2, and so on. Here, AJ is the matrix formed by replacing the J column of the original matrix A with the constant value vector B. Now, let's go through the steps. For step 1, write the coefficient matrix A and the constant vector B, which come from the right hand side of the equation. For the step 2, create new matrices A1, A2, A3, and so on by replacing each column of A with vector B one at a time. For the step 3, calculate the determinant of matrix A and each new matrix A1, A2, and 3, and so on. Step 4, finally find the value of x1, x2, x3, and so on by dividing the determinant of each new matrix A, J by determinant of A. In short, Cramer's rule gives a direct way to find the solution if the determinant of the coefficient matrix is non-zero. It is very systematic method following this simple step. We are going to solve the equation using a Cramer's rule. The three equation is 3x minus 2y plus 4z equals to -5, x plus 3z equals to -5, 2x plus 3y equals 2. We need to make this equation to become our matrix, which is A equals to 3 minus 2 for 1, 6, 3, 2, 3, and 0. For the B is -5, -5, 2. From here, we are going to search determinant of A. We are going to use a covector expansion on J row, which is determinant A equals to AI1 CI1 plus AI2 CI2 and so on. And for this question, determinant of A are going to be A11 C11 minus A12 C12 plus A13 C13. We alternate the sign based on the position of the element. For the first row, the sign are plus minus plus. This gives us the formula like we show in this answer. And from this question, the value of A11 is 3, A12 is -2, and 13 is equal to 4. For the cofactor, it will become like this. For C11 is equal to 0,330, that will be -9, and for C12 is equal to 1320, and it will be -6. For C13 is equal to 1023, and it equals to -2. After we get all A and cofactor, we must plug in into the equation of determinant, which is determinant A equals to 3 times -9 minus -2 times -6 plus 4 times 3, that we will get -27. Then we must search for determinant of A1, which is -5, -2, 4, -5, 0, 3, 2, 3, 0. Then, like the information above, we must find for determinant of A1 using equation determinant A1 equals to A11 times C11 minus A12 times C12 plus A13 times C13. Then we know from the matrix M1, A11 is equal to -5, A12 is equal to -2, and A13 is equal to 4. For the cofactor, C11 is equals to 0, 3, 3, 0 is equal to -9. Then for C12 is equals to -5, 3, 2, 0. N equals to -6. For C13 is -5, 0, 2, 3. And it was equals to -15. After we get all cofactor and also the A, we put in the formula, which is determinant of A1 equals to -5 times -9 minus -2 times -6 plus 4 times -15, and we get -27. So we repeat the calculation of A1 until A3, which is we got A1 is equal to -7, A2 is equals to 0, and A3 is equal to 54. After we know the value of A1 and A2 and A3, we put into the formula, which is Ax equals to determinant of A1 divided by determinant of A, and Y is equals to determinant of A2 divided by determinant of A. Then Z is equals to determinant of A3 divided by determinant A. By using those formula, we know that X is -27 divided by -27, that we get 1, and for Y is equals to 0 divided by -27, which is 0. Then for Z, we know is 54 divided by -27, which is we get -2. And the answer for X, Y, and Z is X equal to 1, Y equal to 0, Z is equals to -2. That's all from the example question, and thank you.